Hello, everyone. I'm Yu Zhou from Tsinghua University. I'm going to talk about flow event telemetry on programmable data plane. I finished this work during my internship in Alibaba Cloud. Today, network applications are becoming sensitive to network performance and have increasing SLA requirements. On the one hand, the increasing speed remarkably raises the expectation of network performance. Applications like block storage services require high throughput and low loss rate. On the other hand, interactive applications have become a major driving force of network business growth, while they also have strong SLA requirements on stable and low latency. If networks can deliver satisfactory performance, we can get guaranteed SLA and great quality of user experience. But bugs and failures in configuration, software, and hardware are inevitable for networks. Thus, applications often suffer from unceasing network performance anomalies, or NPA. Network performance anomalies can severely violate SLA. Even occasional latency spikes can bring unacceptable damage to user experience. There are three major types of NPAs, including long-tail latency, bandwidth loss, and packet timeout. According to 2-year statistics on application performance problems in Alibaba Cloud networks, about 46% of NPAs can be attributed to networks. Considering the widespread distribution and the severity of NPA, operators must do cautious and timely NPA mitigation. For example, assume traffic of an application experiences performance decrease in a network. First, operators should locate the root cause of the NPA by answering the three questions: whether the network or the servers should be blamed, where the NPA happens, and what causes the NPA. Then, operators fix the NPA and recover network performance based on the location information. In production networks, we have observed long life cycles of NPA mitigation that can last for hours or even days. And the NPA location contributes the major part of the overall NPA mitigation life cycle. Thus, NPA location is essential to NPA mitigation. To achieve fast NPA location, operators must be able to correlate flows and events. First, the monitoring granularity should be flow level, because precise information about where and how the application's traffic gets disturbed can significantly accelerate the cause location. Second, operators should be able to precisely capture all performance critical events, including congestion, path change, packet pulse, and packet drops. Unfortunately, existing network monitors are far from satisfying the requirements for troubleshooting NPAs, since they are not designed for capturing flow events. First, traditional switches have black box data planes with weak visibility. Thus, they can only export cause monitoring information, such as counters and logs. With the counter-based solutions, we usually have to combine cause information from multiple sources and guess the root cause, which takes a long time even for experienced operators. The overhead of the counter-based solutions are small, but the cause data granularity cannot satisfy monitoring flow events. Second, as data plane becomes more configurable, packet telemetry is proposed for obtaining fine-grained data plane information. Although packet telemetry can precisely capture flow events, it introduces unacceptable monitoring overheads, since it transmits a lot of monitoring data from data plane to management plane. Existing solutions either compromise scalability or sacrifice granularity. Then, is there an ideal solution that can achieve both fine granularity and cost efficiency? Recent advances on the commodity programmable switches have provided us a new foundation for rethinking flow event monitoring. Our key vision is to perform flow event monitoring directly on switch data plan and export exact flow event information. Then, management plans only need to perform simplistic logic over the flow events. We call this new architecture as flow event telemetry, which can achieve both fine granularity and cost efficiency. However, realizing FET is challenging in three major aspects. First, we should be able to capture as many flow events as possible for fast MPA location, but it is hard to detect all events and achieve full event coverage. We can inspect the packet processing logic in switch pipeline to capture the pipeline-aware events. But some events, like the inter-switch job, happen outside the pipeline and are pipeline unaware. Thus, it is impossible to support full event coverage by simply using the switch pipeline. To overcome this challenge, we propose event packet selection. The event packet selection can not only detect packets of pipeline-aware flow events, but also leverage inter-switch coordination to detect packets of the inter-switch job. The event packet selection supports detecting congestion, packet job, post, and path change. It can be configured to detect traffic of all flows or a specific set of applications. It is efficiently implemented and works at line rate while reducing 90% of monitoring costs. If the switch pipeline is not malfunctioning, event packet selection can ensure full event coverage. The second challenge is high scalability with network sizes. As any packet could encounter events, and there could be a massive number of event packets, it is hard to scale to large-size networks with only event packet selection. To overcome the scalability challenge, we first remove redundant packets by event deduplication, as a flow event could have duplicate packets. Event deduplication can faithfully capture all events without false negatives and reduce 95% of monitoring costs. Then, we remove the redundant payload and headers in deduplicated packets by extraction and batching. We get exact flow events and batches them in an Ethernet packet. Event extraction and batching bring small bandwidth overhead to normal packet forwarding, while reducing 98% of monitoring costs. The last challenge is keeping monitoring accuracy. Due to limited memory in switch ASIC, it is hard to keep high accuracy, and there are false positives in generated flow events. To overcome this challenge, we coordinate switch CPU with ASIC for false positive elimination. The CPU can leverage the massive memory to get accurate flow events with 7% cost reduction. Then, switch CPU will report the flow events to the backend storage via TCP transport, and the flow event reporting traffic will also be monitored by NetSeer. Based on the board designs, we present NetSeer, a FET-based network monitor. We evaluate NetSeer in three aspects. First, NetSeer can accelerate MPA location from the hour level to the second level. Next, NetSeer achieves 100% flow event coverage without false positives. Third, NetSeer is highly scalable with 0.01% bandwidth overhead. For a large-scale data center with 10,000 servers, NetSeer only needs 3 processing servers for FET. This is the conclusion of my talk. Thanks for listening. We are happy to take any question.
Okay, thank you for a very nice talk. Again, you can ask questions on the Q&A here on Zoom as well as on Slack. So I'll start things off. What would you say are the most important optimizations? I assume you experimented with some earlier versions where you didn't have all the optimizations together. So what are the most important things for keeping the cost so low?
I think it's that's a very good question. So the key is that you need to use the programmability and the computation inside the data plane, because that kind of hardware can perform the computation without with negligible performance overhead and cost. So that for the packet processing and for the event detection and the compression, all this stuff, if you can put it in the data plane, we should put it, because it will significantly reduce the burden of the CPU later.
So maybe just to follow up with a clarification, I mean, I see that you're using things like batching. Did you find that that was, sort of got you maybe 90% of the way there, or did you need all of these things working in tandem to get the kind of savings?
Yeah, I think we just reduce the overhead step by step. For example, for the batching, the purpose is that for each kind of event, the data volume is very low, so that if you send each event with a individual packet, that will just create a lot of overhead in the CPU. That's why we in the data plane we form a loop, and it's kind of there will be a packet that's just cycling inside the data plane and get all the events and pack them into a single packet and report that. We found that can significantly reduce the overhead of CPU.
Okay, thank you very much. I see a few questions being typed in, so I'll ask one more while the questioners are still finishing theirs off. So if I understand correctly, you support a fixed set of events that, in your experience, correspond to these NPA anomalies. What would it take to add a new kind of event if you had one? Would that involve sort of rewriting the data plane code? How much of the system would have to be refactored? And have you thought at all about having, a programmable notion of events similar to other telemetry systems?
That's a very good question. Very good question. So first of all, we find that the current 4 kind of event is enough for our NPA purpose, because when you suffer from the network kind of NPA, performance anomaly, it must just something happen to your packet, either it delayed or dropped, right? Or the packet just get disordered. So first, we think the 4 is enough for our purpose. And the second, if we want to add some more types, that only means that we need to modify the first part, the event detection, and the later will be the same. Yeah. Of course, it will be good that we can make this fully programmable in some high level way. That definitely future work.
Okay, one question from the audience. JK Lee at Barefoot says, great work. Did you find any switch feature that would additionally help Netseer if it was added to programmable switches?
Added to the program switches. Yeah, I would say that so currently the MMU, the way we detect the MMU event still have some limitation due to the MMU ability. And in the paper we mentioned that it can be the capacity is capped by the limitation of MMU. And I think if the switch vendor can based on the FET design, they can just enlarge some capability of the inter design. That will be great.
Yeah, thanks for the presentation. So let me have a quick question for you. So basically define, you want to select the packet based on the events, right? So, but in the system, how do you define what is that event? And this detection should be correlated to the prediction of mapping a flow to an event. So if you have different events, if this mapping is not accurate, that might impact your accuracy, right? Could you talk about this a little bit more?
That's a great question. So the first part is that the event type was predefined because we find that because we care about the data plane's performance, and when the application suffer from network performance anomaly, basically it means there's something happened to their packets, either dropped or buffered or paused, or there's a reordering due to the path change. So that these four types are somehow we think are enough for our purpose. Of course, we can define more, but the type are predefined, and the event discovering is just mapping the packets to the events. What the packets happens, those kind of events, and this packet mapped to the flow. So these are the whole process.
Yeah. So from your experience, is there any type of event harder to detect? I mean, you mentioned there are four or five types of events. Is there any event which is harder to detect?
Yeah, just as we mentioned in the paper. So basically, because our data plane is programmable, and so any event that within the pipeline processing is easy to find because we know all the logic of the packet processing pipeline. But what's the most difficult is the inter-switch. For example, if the packet get corrupted on the link, so the packet cannot be reported to the layer 3 pipeline even. So we only see the counters that, okay, there is one packet that has a CRC error. So we either cannot detect the event or cannot recover the flow information. That's how why we design a kind of coordination between the upstream and downstream switch with their programmability, and then detect this kind of event and also recover the flow information of that.
Okay, I see. So another question is that a flow typically traverses through multiple switches, right? So if there are some events for a particular flow, so probably you only need to ask one switch to report this problem instead of asking all the switches along the path to report this issue. So have you considered how to share the loading between different switches to do this telemetry?
Yeah, let me explain that. So each switch only report an event once some event happened inside that switch. So that if a flow has two events happen in two switches, I think the two events should be reported independently because it's useful for the diagnosis. And I think the event is, the granularity is per switch or per link, so that there shouldn't be any redundancy in this.
Okay, I see. Okay.